Hi guys and girls, in this video I will tell you about acoustics as a science. Acoustics, in the narrow sense of the word, the doctrine of sound, is the elastic oscillations and waves in gases, liquids and solids audible to the human ear from 16th Hz to 2020 kHz. In a broad sense, the field of physics, which studies the properties of elastics or oscillations and waves from the lowest frequencies to extremely high frequencies 10 kHz. Their interaction with matter and the application of knowledge to solve a wide range of engineering problems. The term acoustics is now also often used to describe a system of sound reproduction equipment, knowledge of the lives of wave generation, their propagation in different environments, are of great importance in almost all areas of human activity. For general description of the role of acoustics in the modern world, a graphic image created by the famous acoustic scientist Bruce Lindsay, known as the Lindsay Wheel of Acoustics, was very successful. It identifies four areas of human activity in which acoustic knowledge is important: life sciences, earth sciences, art, engineering. Central to this diagram is the basic research in acoustics, which is united by a common name, physical acoustics. Brief historical background. For a deep knowledge of any subject is always important date from the history of its origin and formation. A meaningful analysis of the history of the formation of acoustics as a scientific discipline is presented in many works by various authors. A relatively short but profound description of the history of the formation of acoustics is presented in the work of the famous acoustician R.B. Lindsay. The information of acoustics as an important branch of modern physics began long before the beginning of written history. Understanding that sound occurs during the building of an object against an object and the oscillations of different bodies is one of the oldest elements in the formation of the scientific picture of the world. An important stage in the development of acoustics was the emergence of music. Some archaeological finds indicate that man made a musical instrument from bone with side holes almost 40,000 years ago. It is believed that the first scientific study of the nature of musical sounds was conducted by the Greek philosopher by Pythagoras in the 16th century BC. His research is related to the study of sounds that occur during the oscillation of strings. He established the relationship between string length and oscillation frequency. The study of string oscillations continued in the school of Pythagoras and the quantitative ratios between the frequencies frequencies of pleasing sounds were determined, and general philosophical schemes of harmony were introduced in the world. Important observation regarding the sources of musical sounds have been recorded in China. Almost 2000 years before our era, a system of sound sources was made here which corresponded to the division of the octave into 12 intervals. This monograph outlines the first acoustics guidelines for housing construction contained in the Old Testament. The study of the peculiarities of the perception of music by listeners prompted the search for answers to certain questions related to the physics of sound. Thus, Aristotle has a very clear statement about the process of sound propagation as the transfer of compression tension from one particle of air to another. He also has meaningful considerations about the natures of the human voice. However, he erred in claiming that high-frequency sounds propagate faster than low-frequency sounds. The beginning of our era is characterized by the achievement of understanding of such acoustic phenomena as interference, sound, reflection, etc. Based on the knowledge of the phenomena, recommendations were formed for the construction of ancient treasures, the acoustic properties of which are now spreading many legends. Currently, a detailed analysis of the acoustic properties of the Zwetter excavated by our archaeologists in 1881. Epidaurus, which accommodate up to 15,000 spectators. Studies have shown that the architecture of the theatre formed a chain acoustic filter which prevented the spread of low frequency components of sound, the main components of extraneous noise, and contributed to the spread of high frequency components. Now, among acoustics, one can hear the opinion that such an acoustic discovery was accidental and therefore repeated during the construction of other theaters. The scientific basis of architectural acoustics was created only in the early 20th century. The assessment of the role of the Pythagoreans in different sources varies and is something based on myths rather than actual evidence. The the formation of modern ideas about the peculiarities of oscillatory processes began with the work of Galileo. He performed a significant amount of research to determine the relationship between physical and geometric parameters of strings and the characteristics of sounds that occur when they oscillate. oscillate. He discovered the phenomenon of isochronism, the independence of the period of oscillation of the pendulum from the amplitude, although he mistakenly believed that this phenomenon occurs at any value of the amplitude. He also observed the phenomenon of resonance in general. The end of the 16th and the beginning of the 17th centuries marked a period of considerable interest in the question of the oscillations of strings. In addition to Galileo's research was conducted by other researchers who something surprised Galileo in their publications. Significant advances in determining the relationship between frequency and pitch have been made by the French scientist G. Sauer. It was he who introduced the term acoustics in 1701. He also introduced the terms nodal points and harmonic tones. As with other branches of physics, we can say that with the promulgation of Newton's principles, a new era in the development of acoustics began. Their research was conducted on the basis of new methodological principles regarding the search for scientific results and their justification. Of great importance for the further development of mathematical methods of research in acoustics was the discussion of the string, which was attended by Daniel Bernoulli, Jean-Laurent D'Alembert, Leonard Euler, Joseph Louis Lagrange. The subject of discussion was two solutions of the wave equation for strings. The solution of D'Alembert in the form of traveling waves and the solution of Bernoulli in the form of a superposition of stranding waves. Euler denied the possibility of representing any function in the form of a series of trigonometric functions. The discussion was partly due to the fact that its participants at the time did not know the technique of calculation, the shadow coefficients. The rationale for Bernoulli's solution was obtained only by Fourier. The discussion played a significant role in the development of methods for solving not only the problems of acoustics, but the development of mathematical physics in general. A curtain result of the development of acoustics in the 18th century, we can consider the appearance of the first monograph on acoustics, authored by the eminent experimenter Ernst Agelandny. The first edition of this book dates back to 1802. Many of the observations presented in it found a scientific explanation much later. The book itself looks a bit specific. There is no formula in it, without which in the future in acoustics it is impossible to do. Using mathematical modeling based on well-defined physical concepts has become a powerful means of acquiring new knowledge in acoustics through the works of Euler, Lagrange, D. Lambert, and D. Bernoulli. The result of the process of stronger development of acoustic research in the 19th century was the publication of a two-volume edition of Lord Rayling's Theory of Sound. This work exists in Russian translation and to this day is an important source of knowledge for the study of acoustics. See bibliography. The active research work of many scientists in the 19th and 20th centuries has shaped modern acoustics as a science that covers a wide range of phenomena associated with the creation, propagation of waves and their interaction with the environment. Differentiation came into acoustics, separate scientific and engineering disciplines were formed. Historical research has also begun to focus on individual disciplines. In addition, detailed historical analysis often generates large volumes of publications. Thus, the analysis of the history of Russian hydroacoustics took more than 1,000 pages. A brief analysis of historical facts in the development of modern acoustics in different directions is contained in the Acoustic Encyclopedia. Determination of the speed of sound. The idea of the finite value of the speed of sound based on the observation of the phenomenon of the echo and the delay in the appearance of sound after a cannon shot was formed long ago. The history of determining the speed of sound in the air is quite long and instructive. Regarding the definition of a pioneer is measuring the speed of sound, there are some differences in the literature. The surnames Hazardy and Marsanach are called. Both researchers analyzed the guns shot, recording the time interval after the alarm during the shoot and the time of sound. According to Gasandri, the span was 478 milliseconds. Morn received a slightly more accurate estimate, 415 m/s. Comparisons of observations of cannon and rifle shots allowed Gassendi to conclude that the speed of sound is independent of Quincy. A series of carefully organized experiments to measure the speed of sound was conducted at the Florentian Academy of Experiment until 1616. Measured by the sound of a cannon at a distance of 1 mile, the speed of sound is equal to 1077. The obtained estimate of the speed of 315 m/s remains the standard for experimenters for more than a century. It should be noted that such measurements did not take into account changes in the state of the atmosphere, temperature, pressure, humidity, wind speed. The study of the influence of those factors began only in the 19th century. That is all. Thank you for watching. Goodbye.